Wow, look at this thing. The graph of this function is a straight line with 2 points of discontinuity. So this thing is third degree in its numerator, second degree in its denominator. They're saying if you divide it out, when the dust settles, you're going to get a y equals mx plus b, plus a bunch of things which will cancel out. And those things that will cancel out are where our discontinuities are going to come from. But overall, this thing should clean up to a line. And they ask us what the line is. So what we want to do is factor the numerator, oh boy, factor the denominator, and then see if we can get some of the factors to cancel out. We could do this with long division, and actually I'm considering doing just that. We could write out 2x cubed plus x squared minus 16x minus 15, divide it by the denominator, and see what's left over. But I did the last example with long division, so I feel like I should do one with synthetic. So let's see how that works out for us. We have our numerator, which I'm just going to recopy for now. And I'm going to factor this denominator because I think I can do that pretty quickly. This is, if I do it by decomposition, 2x squared plus 2x plus 5x plus 5. This is going to factor to, if I take a 2x out, x plus 1, and then I take a 5 out, x plus 1. The denominator will factor to 2x plus 5 and x plus 1. Well, I'm not terribly excited about doing this one by synthetic division, so I'll tell you what. I'll divide out the x plus 1 synthetically, and then I'll switch to long division for the 2x plus 5, and we'll get both approaches into one question. So you'll get to see your favorite method as I do this division, and you'll also get to see the other one at work at the same time. So if we have x plus 1, and we're doing synthetic division, my root is -1, that goes there, and I'm dividing 2x cubed plus 1x squared minus 16x minus 15. So 2 comes down. -1 times 2 is -2. 1 plus -2 is -1. -1 times -1 is 1. -16 plus 1 is -15. -1 times -15 is 15. -15 plus 15 is 0. Excellent, it worked. This means we have no remainder. And it means if we divide an x plus 1 out of the numerator, what's left behind is these pieces, 2x squared minus x minus 15. And our denominator hasn't changed. It contains 2x plus 5 and x plus 1. So there's our x plus 1s, which are canceling out everywhere except at -1. That's the reason for one of our discontinuities. Now there's another one we have to locate as well. You might be looking at this and thinking, I can factor that anyway, that's a quadratic, and I think I see it as well, but I'm going to pretend I don't see that and divide this by 2x plus 5, and if you think you have this factored, you can confirm your suspicions in a moment. I'll do this part by long division because I don't really want to work with -5/2 in synthetic. That's messy. So there's our dividend. Our divisor is 2x plus 5. Let's see what we get. 2x goes into 2x squared, x times. X times 2x is 2x squared. X times 5 is 5x. 2x squareds cancel out. Minus x minus 5x is minus 6x. And start over. 2x goes into minus 6x minus 3 times. Minus 3 times 2x is minus 6x. Minus 3 times 5 is minus 15. I'm sorry, I should have brought this minus 15 down. That's what typically happens. Those cancel and we get 0 left over, so when we take a 2x plus 5 out of here, I'll write this one last time. With the 2x plus 5 taken out, what's left at the end is x minus 3. downstairs we have 2x plus 5, and we have x plus 1. So you can see we have x plus 1's here. These two factors are going to cancel out basically everywhere. They'll both be 101, and then they'll both be 100, and then they'll both be 99, and there will be an infinite number of places where these numbers are identical and they cancel out. But there will be one place where they don't cancel out, and that's when x is negative 1. At that point, we get 0 over 0. That's undefined, and so when x is negative 1, this expression does not exist. That's what they're talking about when they say there's a point of discontinuity. One of those will occur at negative 1. The other one will occur because we have these 2x plus 5's fighting it out. And they will cancel each other out everywhere except at minus 5 over 2. X is not allowed to be minus 5 over 2 because if it is, those two terms go to 0 and the function blows up again. So those are our two non-permissible values, and with them out of the way, we can see here's our well-behaved piece. 99.9% of the time, these guys are busy canceling out, not making any difference because they're just equal numbers which don't matter. And so the function behaves like x minus 3. This expression will behave like y equals x minus 3 as long as you stay away from its two hot buttons, these values. Everywhere else, this thing behaves like a perfectly nice straight line. It's going to look like x minus 3 except with two little blips in it, and everywhere else it'll be indistinguishable from that straight line. Now, what else do they want us to do here? Determine the coordinates of the points of discontinuity. Well, you remember, we said x is not allowed to be negative 1, and x is not allowed to be negative 5 over 2. And 2x plus 5x minus 3. I'm going to have to copy that down here. Excuse me a moment while I copy this, and then I'll scroll back down and we'll get back to work. I'm just rewriting the function x plus 1, 2x plus 5, x minus 3, and it's all over 2x plus 5x plus 1. Okay. So, at negative 1, this function can't exist because these two terms go 0 over 0, and that makes it undefined. But what if they weren't there? Pretend for a moment that we'd had lost the x plus 1's, and we were just working with the rest of the expression. We'd have 2x plus 5, x minus 3, over 2x plus 5. We're saying, okay, how about these guys? U factors that don't blow up at negative 1, what do you say the value of this line is? Well, I can save a little bit of time by canceling these out. They're perfectly well defined at minus 1. We get the line is behaving like x minus 3, which is negative 4. So one of our discontinuities will be at negative 1, negative 4. The other one will be when we have minus 5 over 2, which is minus 2.5. I'm going to go decimal for a moment just to make this go a little faster. If we know that these numbers are canceling out, and we know that these numbers are canceling out, we're just pretending that they aren't there for a moment, and we're saying, okay, line, the part of you that's actually defined everywhere, what would you do at minus 2.5? And the line says, well, I would be at minus 2.5 minus 3, which is minus 5.5. So negative 2.5 comma minus 5.5 is our other point of discontinuity. While these terms are busy going undefined and breaking the equation and creating discontinuities, this is the reasonable part. This is the sane part of the equation, saying, if it weren't for them, here's what I would do at negative 1, and here's what I would do at minus 2.5. I can't do it. You'll actually see me have hiccups there because of these other crazy factors I'm attached to. But here is what I would like to do. I would like to hit these two coordinates. And make a rough sketch of the graph. You know what x minus 3 looks like. It's going to be a line with a slope of 1 and a y-intercept of 3. So our curve is trying to do this, except at minus 1, minus 4, it'll have a blip, and at minus 2.5, it'll have another blip. These will not show up well on the calculator, but if you actually key in these values, negative 1 and negative 2.5, the calculator should say error, and that'll show you that yes, indeed, there is a little hiccup in the function, or what we call a point discontinuity for each of those two values.